Later, we will hear about directly from the teams behind the two of the AEGIR's 4 European demonstration sites, the Spanish demo in Malgrat de Mar and the French demo in Boën-sur-Lignon, as well as from our digital technologies partner, IDP, on BIM-based modeling and digital workflows. But in the right time, Lina, you can stay on that slide. Before we get into the content, a few housekeeping points. There are 3 things. Please note that this session is being recorded. Please keep your microphone muted and your camera off during the presentations. This would tremendously help us on managing the audio quality and everyone in the room. And if you have any questions at any point, please post them in the chat or use the Q&A button. We will address all the questions together during the dedicated session, Q&A session after all the 3 presentations. Thanks again, and let me show you what we have planned today for you. Next slide, please. And here is our agenda for this afternoon. I will take a few minutes to introduce the session and the AEGIR project, and glad that our project coordinator is here, so he can also say a few words about the project, the AEGIR project and the whole background about it. Then we will move on to the municipality of Malgrat de Mar. Victor will shed some light on the Spanish demonstration, the school retrofit. Then we hand over to Vaneva from CL who will present the French demonstration. Later, we will hear from Sergio from the IDP, who will cover the technical focus on BIM-based modeling and integrated digital workflows. We will then have 15 minutes for the Q&A, and we will close the session with a few key takeaways. Now, let me start right away with a quick icebreaker. So please keep your chat open. We will just post a few very generic questions on the chat, and please take a second to just answer and to see who's joining us from where. So we will start with the first question. Maybe Alina or Ella will. Yep. All right. I see it on the chat. Please take a moment to just write on the chat and say, okay, all right, Cambridge, UK, France, Lugo, Spain, okay. Brussels, Pamplona, Bilbao. Whoa, it's spanning all over Europe. That's fantastic. Great, keep on sending it, but then we will move on with the next question, which is on what best describes your organization. There are a few options there, like city or municipality, regional or national authority, housing association, and so on, construction or engineering company. Again, that's fantastic. We have city representatives, we have others, we have research academia. Great, engineering company. That's really interesting. We have pretty much all the stakeholders mentioned. And then the third question is, what is the biggest barrier to deep renovation in your context? We know there are a lot of barriers especially on renovation across Europe. We know financing is one of the biggest challenge, but there are other issues and barriers. So yeah, let's see how we funding and financing. Yeah, it's not an easy. Great. Feel free to put your answers. I mean, we can continue on the chat, but now we will move on with a brief overview of AEGIR. And here, since we have our project coordinator, we're glad he joined. Yulen, I'll pass the baton to you for the next, I believe, in two to three slides. There are.
Okay, so thank you very much to all of you for attending this workshop. Taking into account that our idea until the end of the project, that is going to be during the next year, is to have different workshops around the demos. At this moment, we haven't finished all the demos, but in the next months, we will have these webinars, workshops close to each of the 4 buildings that we are refurbishing in the project. And also, we are going to be able to provide you with more information and collect the comments about how you see the approach that we are following in this project. AEGIR project is an European project under the Horizon Europe Framework Program. And it's a big project. We are talking about 29 partners from 9 countries in Europe. And the idea is to define new ways of refurbishing buildings using physical components, facade components, ventilation components, energetic elements, but also combining them with a digital approach of how we can improve the way that we are using the systems of the project. So the idea was to have a modular industrialized renovation system to reduce cost and time. We are integrating renewable energy in the building, and also we are going to have different tools in order to manage this energy, trying to have the buildings converted into nearly zero energy buildings. As commented, we have different renovation packages. The idea of the project is to have incremental packages in order to refurbish the buildings based on the requirements that we have from the owners and the possibilities that we have for each of the buildings. As commented, we have a full digital ecosystem that goes from helping the architects to design and also to help the users to operate and maintain the building in the best ways possible. We are using also a combination of bio-based and recycled materials because circular economy and reduce the embodied carbon is one of the key points that we have in the project. And also, obviously, the idea is to have an approach that is user-centric, taking into account the requirements that we have from the users, and also using these systems to improve the indoor comfort and the way that the users are going to behave in the buildings renovated with the system of the project. I don't know.
Maybe move to the next slide is on technologies. Julian, you might continue on.
Okay, as commented, we have different technologies that goes in topics like construction, energy, or digital. So we are talking about industrialized envelopes, the use of biocomposite in the profiles of the project, but also in the insulation, providing better performance, better thermal performance and acoustic performance. Also, we have a solution that integrates ventilation ducts in the facade in order to improve the ventilation capabilities of the building. And this is something that is combined with some smart windows that are controlled by the BMS or the digital twin of the building that improve also the ventilation of the system. Related to the renewable energies, we have some approaches using solar collectors and flexible photovoltaics. And also we are using second life batteries in order to help in the management of the energy generated by the renewable technologies. And the tools that we have in the part are quite a lot. So we have a common data environment, a facade configurator. We have some tools in order to collect the data from the real building in order to improve the refurbishing. With this data, we are able to generate a digital twin of the building. And also we have some technologies to help the execution of the system on the final buildings, but also to connect the data from the building with energy meta models that help us to improve the building operation and the maintenance.
Right, maybe move. Next slide. I think now it's should be on the AEGIR. Thanks, Julian. Thanks a lot.
Okay, thank you.
Thank you. And now we let me explain on the a little bit on the workshop series. The demo-led replication workshop series is designed to bridge the gap between technical demonstration and the market-wide replication. The primary goal is, of course, to share practical insights from real-life demo sites with the stakeholders, including architects, engineers, policymakers, and building owners. And these workshops are not just about showcasing finished product; they are about transferring knowledge from people who have done it and the people who are thinking about it. So, next slide. What these workshops are built on is the evidence generated by the demonstrations themselves, the technical solutions, the regulatory and permitting context of each country, and the construction sequences. Every demo follows the same common process: assessment, design, procurement, construction, commissioning, and all these steps kind of represent this replication framework. And finally, they delivered the structured replication pathways that actually takes to apply to this approach in a different building or city or country. Direct input into the AEGIR's work on green public procurement guidance, financing models, and as well as other regulatory recommendations. So I'm sure your questions and your barriers today will feed into our wider work. Maybe next slide. And a little bit on the objectives. We aim to share practical insights from the real-world demonstration sites, and then explore technical feasibility and modular design strategies, discuss strategies to overcome financial and regulatory barriers, adapt solutions, and of course foster transdisciplinary collaboration for the scaling up actions. So all five are really relevant and what we will hear today. And now with that, we move on to our first demo speaker, and our first presentation is the Spanish demo. Victor from the municipality of Malgrat de Mar will present the school retrofit, a public elementary school built on Mediterranean coast of Catalonia. Victor, I'm happy to give the floor back to you on next 10 minutes. You will show us the Spanish demo. Thanks.
Thank you, Bar, and thank you, Julian, for the introduction. And as Bar said, I'm Victor Martinez. I'm here on behalf of Malgrat de Mar municipality, which is one of the demo sites of the AEGIR project. And today I'm here to present the Spanish demo site. And what we have already done so far is the previous analysis on the project. So you know that across Europe, a large portion of buildings are outdated, inefficient, and are responsible for a significant share of energy consumption and carbon emissions. However, conventional renovation methods are very slow, invasive, and very difficult to scale up, and highly disruptive for users and occupants, which is one of the main constraints when we talk about energy retrofitting or refurbishment of buildings in general. AEGIR addresses this challenge in a very innovative way, proposing a modular prefabricated facade system that integrates multiple building technologies into a single intervention. The AEGIR concept, as John has already said, the concept is based in industrialization of renovation, and instead of treating the insulation, ventilation, energy systems separately, AEGIR integrates them into prefabricated facade modules. This creates a multifunctional envelope capable of reducing heat transfer, generating energy, renewable energy, managing ventilation, and enabling smart monitoring. Please, next slide. Here you can see how the school, which is a demo site in Malgrat, looks like nowadays. AEGIR concept has a systemic approach and integration that is the key innovation of this project. As Bar said, the Spanish demo site is located in Malgrat de Mar. For those of you that don't know where Malgrat is located, we are just 60 kilometers north from Barcelona at the Mediterranean coast. So we are showing how the project performs in the Mediterranean climate. Our climate is characterized by higher solar irradiation, significant cooling loads, and seasonal humidity variations. Next slide, please. Yes. The building is an operational school which adds constraints related to safety, noise, and scheduling. The school has almost 400 students from 3 to 12 years old from 24 different countries. And when we planned the project, we have several concerns. Among them, the most important concerns were how to engage the community since the very early stages of the project. I think that we have succeeded with that because the principal and the community have been engaged since the very beginning. They are happy about the project. They are lucky because the school will be changed, will be more efficient, will be more modern. And I think it's the first success of the AEGIR project. The second was how to find out the best solution for the irregular surfaces of the facade, because as you have seen in the previous slide, the building is not a simple building. It's complicated because it has a lot of irregular surfaces. Another concern was how to integrate the solution with the local energy community in progress in the city, because the idea is to use the surplus of the energy production with the energy community running nowadays in Malgrat. And last but not least was how to integrate the new biomass boiler recently installed in the building. Next slide, please. Before the intervention, we were planning or thinking about what should be or what could be the different risks that we will have to face. Among them, we can highlight the tendering process of the installation, because here in Spain, we have a lot of constraints when it comes to talk about legal contract in public departments. So it's very tough for us. One public tendering could last several months, and we can't afford that. The second is the schedule of the implementation. Even AEGIR strategy is a non-disruptive or option. We were concerned about that, and it's one of the main risks that we have to face. The commissioning of the installation is another risk because we don't have experts in our site for such an innovative solution, and how we will maintain the installation in the future is one of the main risks. I think all of these risks are being solved nowadays, but I'm talking about our experience before the project. The lack of engagement of the community, as I've already said, the community is really engaged. Low performance of the solution is solved. We don't know. We hopefully expect that it will perform perfectly because now we are in the project stage. And the potential damages on the building during works, we don't know yet because the works are starting in the coming weeks. Next slide, please. During the previous months, we have yes, thank you. We have carried out a detailed BIM model using laser scanning and survey data. This model includes architectural geometry, structural systems, mechanical systems, and it was used to perform energy simulations, daily light analysis, solar exposure of the different facades, and clash detections. And the BIM model serves as a base support for the digital twin that is developed within the context of the project as well. You can see in this image that the solar analysis carried out has identified different areas of major solar exposure, and different facade configuration have already tested to optimize the daylight and solar exposure to minimize the impact of this high exposure in such moments of the day. The key innovation of the project is the angular facade design you can see here, which reduces the overheating while maintaining natural light. You can see different angles on the modules. This demonstrates how architectural design can directly improve environmental performance. This reduces solar gains while maintaining daylight, as I've already said, and this balance is critical for thermal comfort and visual quality in classrooms. Please, next slide, please. Now we are talking about the facade design. The facade system is a ventilated modular envelope composed of prefabricated panels. Each panel includes external cladding, as you can see here, air cavity, insulation layer, and internal support frame. The ventilated cavity improves moisture management and thermal performance, and the facade geometry is angular, optimized to reduce solar gains, as already said, and improve shading. A thermal performance was evaluated using European standards, and the facade significantly reduced U values. At least we hopefully expect that, improving insulation performance. Thermal breaches at joints were analyzed using finite element methods and minimized through design optimization. This results in improved energy efficiency and reducing heating and cooling demand, which is important for us because the building is a very big building with high energy demand so far, and I will expect that the energy demand will reduce considerably. Please, next slide. When we talk about materials, the different partners of the project were discussing during several months about which materials should be best to be used in Malgrat, taking into account the different characteristics of the facade, the weather conditions, and so on. The different materials selected were fiber cement panels, aluminum, reclaimed wood, which is important because it increases the circularity of the project, and bio-based insulation. All of these materials were selected because of their durability, low environmental impact, and compatibility with prefabrication. And the facade used a combination of the different materials. As you can see here in this picture, you can see that the white panels are fiber cement panel system. Then you can see the wood in the back of this image. There are different combinations along the different facades of the building. As well, the project includes some parts of the building with perforated aluminum mesh screens installed in different areas just to provide ventilation and solar shading. Next, please. Here you can see as well the different materials and the aluminum mesh in the lateral facades of the building. These lateral facades includes as well the ventilation ducts that the project has designed them integrated externally because of their size, their size requirements. Sorry, because they are big ducts, and these solutions includes or more than includes will ensure an adequate airflow inside the classrooms. Nowadays, we don't have any kind of ventilation of the classrooms. A compliance with indoor air quality standards, and minimal interior disruption. The new ventilation systems will improve the air quality because now in the schools we don't have, as I mentioned, we don't have any kind of ventilation. It will improve as well the thermal comfort because now we don't have any kind of climate systems inside the classrooms for summer seasons. Yet in winter we have heating systems, but not in summer, and it will help the internal thermal comfort. When we talk about next slide, please. When we talk about renewable energy systems, PV panels will be installed on the roof. Previously, we have had to check the stability and the capability of the roof because there is, you can see here in this design, there are a lot of weight on top of the roof. So we had to make sure that that the roof could be able to support all these weights. And the renewable energy systems include not only the PV panels, but as well the inverters, as Julian mentioned, battery storage systems and the energy management systems of the installation. And as I told before, the energy surplus of the PV panels will be shared with the energy community in the municipality. Nowadays, I think, Julian, if I'm not right, please correct me, the modules are being manufactured off-site, and in the coming weeks they will be here in Malgrat, so we are going to be able to start the works on site. Likely we are with a bit of the delay, but likely we will start the works very, very, very soon, and the project will be a real fight very soon. As well, we have sensor monitor environmental and energy parameters on the school. We have included sensors, temperature sensors, humidity sensors, CO2 level sensors, and the energy production. So we will have real-time information to monitor the system during the coming months or years. If we talk about the expected outcomes, we are planning or the project expects a 60% of reduction of the energy consumption, along with significant improvements, as I have already said, in the indoor comfort air quality. And that's it. In the slide, you can see here the different configurations of the facade. The facade will include, some of them will include the prefabricated modules. Some other ones will be improved by AEGIR. The green one, you can see here, will not be covered with prefabricated modules, but with AEGIR different systems. We will have to design a specific place for the HVA system, which is very big. You can see here the dimensions of the equipment and the different ducts. Will have a very huge impact on the image of the building. And in conclusion, we can say that the Spanish demo will represent, or I think that so far represents, a comprehensive and scalable solution for building renovations, which is one of the main problems of the local authorities across Europe. We have a lot of buildings, old buildings, and we don't know how to retrofit them with a non-disruptive solution. I think that AEGIR will demonstrate that it's possible. Of course, it's a very expensive project, but I think that it's a good option for all the buildings in Europe. Next slide, please. And this is how the school will look like after the works of the AEGIR project. As you can see, it's a very spectacular change. So that's why the local community is very happy with the project. They are really engaged, and they are willing to make it a good option to demonstrate that the school will change the image and to engage more people coming to this school, because I didn't say it, but this school has a lot of immigrants there, so it has a kind of negative features. I don't know how to say it. That there are a lot of people that don't want to go to this school because of the 24 different nationalities, and I think that it will help to reduce this kind of difficulties for the school. And that's all from my side right now. If you have any questions, I'm open to it. Thank you very much.
Great. Thank you so much, Victor. This is amazing. And yes, it's all about making the community happy and, of course, serving the best we can. Yes, we will come back to questions, but please start inserting them either in the Q&A or the chat. And then when we open the Q&A session, we will for sure invite Victor to answer those. Now, we move to French demo. And I'm very happy to invite Faneva from the CIL, who will present the elderly housing retrofit in Boën-sur-Lignon. Faneva, the floor is yours.
Yes, thank you for the introduction, and hello everyone. Alina, please can you share the screen? Thank you. So my name is Faneva. I'm the innovation officer of CIL. CIL is a public authorities in department of Loire. We are specialized in the field of access to electricity, renovation, and we support local authorities and municipalities for energy saving and energy efficiency. So today I'm glad to present you the French demo site, which is Astrid residence in the municipality of Boën-sur-Lignon in France. Next slide, please. Boën-sur-Lignon is a rural municipality located about 1 hour from Lyon, and there are like 3,000 inhabitants. Astrid residence was the construction of the Astrid residence is in 1981. The building is like 3,300 meters square, and it's like it's a building for social residents and for elderly autonomous senior. Today, the heating system is with gas boiler, and there are not renewable energy in the place. The building is a four-level structure with a total surface, as I said, around 3,000 millimeters square. And it is a good demo site because it's different between the other demo site in AEGIR projects. Next slide, please. The objective of the project is like to develop modular, renewable, and industrialized building in order to promote energy renovation. In the French demo site, we will test and deploy a solution that are developed by partners like Chazelle, like Soprema, and so on. The aim is to develop two solutions which will be replicable in the whole European scales, and the objective is to reduce cost and to reduce the time of the construction in order to accelerate the renovation, and to accelerate the projects. So here is like the Boën-sur-Lignon municipality. In the French pilot, so many solutions will be implemented, and like prefabricated façade panels. We will use two modern ventilation system, an active smart windows, and we will integrate renewable energy solution, and even we will use a second life of battery for energy storage. At the beginning of the project, CEL has made the energy audit of the Astrid residence, and our energy audits show that the AEGIR project may reduce around 40% the energy consumption of the residence. So next slide, please. So here is like the actual image of Astrid residence, and here is like the design for AEGIR project. I know the design will be changed, and it's like a challenge. So some challenge that we faced up is like to minimize the impact of the on-site work for residents' comfort. As I said, the renter of Astrid residence or the elder person. So I'm like to reduce the displacement of the resident during the renovation. Some challenge to how to integrate the solar control, and how to integrate to the solar shading in order to allow the maintenance without like reducing the daily light, and to facilitate to the ventilation pipe integration. The ventilation will be integrated in in the facades, and the actual isolation. So then some challenge too is to the integration of the ventilation to the system, and one of the main challenges is like about range regulation, how to link French energy performance requirements to have house in operation, and how to accelerate to the French administrative, and to reduce like the time of the project. So next slide, please. And actually, I will show you the design of the facade. So here is like the front design. We will use like two types of panels, array panels and a flat panel. For the windows, here is like an example of the image that we want to have at the end of the project. And for panel anchorage, aluminum will be used for the top of fixation. The solution that is used is a modular prefabricated timber facade system that will envelope the existing buildings. It will be, like I said today before, we will integrate to renewable energy solution, and we will reduce like the displacement of the residents. Like the aim is to remain them in the place during the renovation process, and it's like used to divide the work in order to reduce noise and to reduce the dust, and to accelerate the access. So next slide, please. So here is like the BIM models of the S3 residence. It is used for simulation, and like to modelize all solution, and like it is adaptable for buildings geometry. Next slide, please. Using next slide. Thank you. So now for renewable energy solution, we will integrate in residence S3 roof like 148 PV panel. We will use dual sun flash 155 top cone glasses, and for the hybrid panel, we will use the Spring Max 455 water peak. For the heat pump, like we will change the actual heat pump, and we will change the gas boiler. So we will use a water heat pump. A new gas boiler will be integrated, and it will like ameliorate the comfort of the residents. For ventilation units will be integrated too, and will for energy storage, a battery, second life of battery will be integrated. Or the solution will be managed by the energy management system that is developed by Catalonia in order like to accelerate for energy efficient and for energy saving. So next slide, please. So here is like the shape for the ventilation and heating system. We will couple the for the water the PVT panel for water part to the water heat pump. And like as I said before, in this case, we will change to the gas boiler to a new one and a smallest one. Next slide. So the final renders of the French demo site is this one. I think AEGIR project will ameliorate the living condition for elderly person in residence as 3. It will improve too the renovation building process. And thanks for your attention. Pauline, do you have something to add?
No, thank you, Vanessa.
Fantastic. Thanks a lot, Vanessa. We are really running a bit out of time, but we still have our technical partner, the IDP, Sergio, presentation. Sergio, if you can finish it up in 10 minutes, that would be great. So we at least have 3 minutes on the Q&A, but maybe we can also spill over a bit over after 3 o'clock. But here I would pass on to you, Sergio, for your presentation. Thanks a lot.
Okay, thank you, Art. Yes, I will try to be fast. Okay, so the intention of this presentation is to present the digital aspect of the project. My name is Sergio Velázquez. I am from IDP. We are an engineering company located in Barcelona, and we try to cover all of the scenarios from the design to the installation and operation of the projects. Please, the next slide. Okay, this is a very complex project. The project is composed of different disciplines involved, not only architecture, but also engineering, technical development, and digital aspects of the project regarding the design and the monitoring. So the idea was to elaborate a parallel development, implementing different services based on digital information and data. These services are focused on creating an ecosystem that supports the progress of the 4 demo sites, providing all of the information in one site in a common data environment. And then this information can be used not only for the design, but also for the next engineering and execution projects, and the end to the monitoring and the maintenance after the project ends. This is more or less the scope, and these tools are summarized here in this roulette. The 14 services are going to be explained. Not all of them are ready at the stage of the project now, but most of them has been started and others have been implemented completely. The next, please. The complexity of the project for each demo site starts with the list of factors involved. There are different actors like the owner of the demo site, and then the project manager in charge of managing all of the actions regarding the needs and the requirements for the specific place. The architects, the engineering companies, the designers, most of them are requested to produce the information and the data in a common standard, which is some BIM related software. And then the manufacturing companies and the final users also are consulted, but at the end, this configuration of factors is very, very complex to manage. with this team created, we go to the next stage, which is the strategic concept design, the technical design. Now we are in the phase of the construction and renovation, and at the end of the year, we hope to have the handover and close in order to create the next scenario functionalities which are related with the exploitation of the buildings and the new projects. The next, please. This is a kind of orchestration process, okay? This is the summary of this slide. The next, please. Okay, as I mentioned before, the different actors involved produce and creates a lot of information. Other information must be gathered from the current situation of the buildings. All of the buildings are existing houses, existing buildings. So some of the information when they were built were in paper based, not digital, and this was a very complex aspect to manage. So the idea was to use several tools in order to create the information in modern status like digital models, and we use several strategies, creating the basic models, 3D models on the paper information, and also creating the models from laser scanning technologies with the support of engineering companies at the University of Cambridge, for example, and then we produce the models. With this information, we could start working on the facade designs. Tecnalia provided some technologies regarding the facade configuration models based on the existing conditions and the outcomes of the project in terms of the energy efficiency. And these alternatives are considered later on with the designers and architects in order to provide suitable designs for each demo. Next, please. For the purpose of this information workflow, we require to implement a common data environment. So CSTV, a French research institute, provided the infrastructure to create this common data environment where we manage all of the information regarding the project. The next, please. Next. Okay, the process, as I mentioned before, is a very complex task. We started from the existing information available and supported with other technology to create the models. As you can see, the sources are diverse in nature. Some CAD models, maybe some IFC-based beam models, others coming from laser scanning. And then this information must be processed. And as a result, we created a platform where this information is displayed in a 3D model. This platform is called the Digital Twin Platform, where the digital services are integrated and implemented. The next, please. For the facade, which are the new elements to be included, we started from the existing building models created, and then the alternatives of the facade were studied, and then this is managed by the designers, as you can see in the right side of the slide, and then with the new model, including not only the facade, but also the solar panels and ventilation, as in this case, in the case of Spanish site. The process has been completed with this process. So as soon as the installation process starts, new technologies like the augmented reality to verify that the facade elements will fit properly within the building or over the building will also be tested. Okay, the next one. The ventilation models were also modeled in BIM. The idea to use BIM is to reduce time in designing and creating the scenarios virtually in order to complete the design and to deliver the project to the engineering company. At the same time, we started to use the sensors installed. For this purpose, we created a space model of the building in order to locate in the three-dimensional view of the building the location of each sensor. So the main parameters evaluated has been the temperature, the humidity, and the CO2. But as soon as the electrical components based on the photovoltaic panels, we also will include parameters regarding the energy efficiency monitoring. The next, please. We also implemented some basic tools like the irradiance calculator in order to evaluate and estimate the capacity of solar production for each demo site. As you can see here, we have implemented the tool based on the digital twin and the BIM models for the French and the Spanish demo site. So this is the basic information source in order to calculate and estimate the potential production during the solar daylights. Okay, the next, please. As a result, we have implemented these tools in one site. This is a web service platform, and the different components have been defined as digital services or components. The next, please. This is the Spanish demo site in the digital twin platform. As you can see here, we started working with the existing building in the left side, and in the right side you can see the new model. In this case, we have not included the facade yet because we are creating the new federated model. But the sensors are installed, as you can see in the bottom part of the right side, with the sensors installed. But new sensors will be integrated when the new facade and the new ventilation and solar photovoltaic panels are finally installed. The next, please. In the case of the French demo site, here again, we have the previous building and the new project based on the solar installation. At the time we implemented this model in the digital twin platform, the facade design was not ready, but it's a question of federate the models together with the ventilation model in order to have the same digital twin platform of the project as the previous one shown in the Spanish demo case. So as you can see here, all of the services have been included from the inventory of components to the other digital components regarding the materials and information about the materials, the digital logbook of the demo site, which is focused on the follow-up of the new construction in order to have information about the process in the maintenance aspects of the new components installed, because this is one of the main outcomes of the project, to try to maintain the new solutions in good conditions and providing the comfort and energy cost reduction as proposed in the project. Okay,
Sergio, thank you
That's
so
all.
much. We have just hit the time. Unfortunately, I think we, I mean, I don't see any question, but is anybody interested to take any, I mean, to pose any questions? I don't see anything on the chat. If not, then we will close it, but please follow up with us, and we will be really pleased to send any answers to your questions. Anybody wants to take the floor? I see one question for the Spanish demo. Are you going to do something different from the conventional renovation besides the prefabricated facade in order to complete the renovation? Victor.
Sorry. Well, when the project is done, I think that the school will be in perfect shape. So I don't think we don't have to do anything special there.
Mm-hmm.
We will make other projects, but not in this building. In other buildings, yes, for sure. And we will use all the knowledge that we have or that we will have learned during this project to implement in another buildings, but not in this one, because at the end of the project, this building will be perfect.
Great. Thanks a lot. People are waiting to kick me out of my booth, so I'm sorry, but I have to close this workshop. Thank you so much for joining, and please join us on the next one. We will share with you the information. It's on either on 29th or 30 April for the other two demos. Thank you so much, and until then, see you soon. Bye-bye.
Thank you very much.
Thank you.
Thank you all.